Today we are in Unit 5, Lesson 2. Again, we're in Chapter 11 out of the textbook. We'll be talking about distributions of data. The content standard that we're going to focus on is understanding statistics as a process for making inferences about population parameters based on a random sample from the population. The mathematical practice that we'll be focusing on is make sense of problems and persevere in solving them. We're going to start off with another key concept. This concept is about symmetric and skewed distributions. So we have two kinds of skewed distributions. Skewed means essentially off-center or not symmetric. So we have a negatively skewed distribution. This is also called a left skewed distribution. This is skewed towards the lower end of your data. You can tell the direction of the skew by which side the tail is on. If the tail is on the left, it's skewed left, it's negatively skewed. If it's skewed right, the tail is on the right, it's positively skewed towards the higher end of your data. You'll notice in these pictures that the mean is closer to the tail than the median. The mean, again, is the average of your data, and the median is the middle number if you arrange all the data items in order and find the middle number. Again, on the positively skewed, the mean is closer to the tail than the median is. And for a symmetric distribution, the mean and the median are identical, and they're right down the center. Example 1, we're going to be looking at describing a distribution using a histogram. The scenario is about presentations, and it says Ms. Schroyer's students each gave a presentation as part of their class project. The length of each presentation is shown in the table. Part A says that we need to use a graphing calculator to create a histogram and then describe the shape of the distribution. At this point, you might be panicking because you don't have a graphing calculator, or maybe you're excited because you do have a graphing calculator. But this is the point where you really need a TI-83 or TI-84 graphing calculator in order to create a histogram, because if you don't have one, you're going to be doing this by hand, and that will take you a lot longer to do the work. But what I'm going to do is I'm going to try to pull in my graphing calculator on the screen here, just so that you can see the process for doing this. Let me shrink down my window so it fits in the screen here. Okay, so actually I need to move it around a little bit more because I want to be able to see the table over here. Okay, so we have all these data in this table. What we're going to need to do is to go to Stat on the calculator. Bring it over here. Okay, so if you click on the Stat button on your calculator, you'll see this menu over here. We're going to go into the Edit menu, hit Enter. We need to type all of this data in List 1. If you have any information in List 1, what you want to do is go up to the top, so it's highlighted, hit the Clear button, and then the down arrow. Do not ever hit the Delete button, as it will mess your calculator up, and I'll have to fix it. So now what you're going to do is just type all your data in. So we have 17, 15, 13, 17, next column 13, 23, 20, 19, next column 11, 7, 12, 20, next column 17, 16, 21, 18, last column 20, 10, 14, 19. And the order that you put these numbers in does not matter at all. I went down the rows, you could go across, you could go random, it doesn't matter as long as you get all the numbers in. So then the next thing over here, after we have our data in, This is just them describing how to do it. We put stat enter, and then we put all our data in. Then we're going to go up to the stat plots and choose the histogram option, and then look at the window. So let me pull this back in here. We're going to go to second, and then up here it says stat plot. It's very small, so second y equals. We're going to go into plot 1. It needs to be on. I'm going to make this window a little bit bigger. The histogram is this option right here. So to get there, you go down to the type, go over until that's flashing, hit enter. Now it's selected. You need to make sure that your X list is list 1, where you had your data. So if it says anything else, you would go down here and you hit second 1 to make it say list 1. Similarly, second 2 would be list 2, second 3 would do list 3, etc. I have a color one because I have the 84 Plus in color edition. Color doesn't really matter. What you're going to need to do next is go to zoom and then 9. And this makes our histogram of the data. If you hit the trace button, you can see that in this bar there are 2 points. And these are any of the numbers that are below 10.2. So if we look back here, let's go back to the screen. Let's go look at the data again. How many numbers are below 10.2? Well, there's 2. There's 10 and there's 7. That's why there's 2 here. If I go to the right arrow, that'll show me the next bar. There's 4 items here. These would be anything below 13.4 and above 10.2. So looking back here, we have 11, 13, 13, and 12. Those are our 4 items. So that's essentially what a histogram is. It shows the bar height is the count of items that are in a particular category. Okay, their bars look different from ours. You can see that. What they did is we need to adjust the window to the dimensions that are shown. So we need to have our X scale be from 3 to 24. We're going to count by 3s, and we're going to go in Y values from 0 to 8. So the way you do that over here is you go to second, not second, you just go to the window button. You need to go from X-min from 3 to 24. Our X scale is going to be 3. Our Y values are going to go from 0 to 8. We're going to count by 1s. Scale 1. And then we can go back and look at the graph again. And now you can see this bar graph looks identical to the one that's over here. So for this one, if I hit trace again, how many numbers are less than 6? None. How many numbers are between 6 and 9? 1. How many are between 9 and 12? 2. Between 12 and 15? 4. Between 15 and 18? 5. Between 18 and 21? 6. And between 21 and 24, there are 2 numbers. Coming back to the lesson, this says the majority of the data are on the right side of the distribution, meaning that it's higher over here. You can see if you were to put a curve over this, the tail will be on the left side, so it's left skewed or it's negatively skewed. Part B, describe the center and the spread of the data using either the mean and the standard deviation or the 5-number summary, and justify your choice. And right now, you have not been told how to choose between mean and standard deviation versus 5-number summary. You may not even know what a 5-number summary is. But here is the difference between the two. Whenever you have a skewed data set, you should use a 5-number summary. Therefore, if you have a symmetric data set, you should use the mean and the standard deviation. So the way you get to the 5-number summary is you are going to go back to your calculator. You're going to press Stat, go to the Calculate menu. 1 variable statistics. Your list is list 1. You're going to go down to Calculate. If you have an older version calculator, I can't display it on here, but essentially what it's going to do is it's going to have the one variable stats command after you click on it in the menu is going to be just on the main screen, and it's going to have a blinking cursor after it, and you're going to need to press list 1 so that it pulls the data from list 1, and you do that by hitting second and then L1. So your screen would say 1 var stats and then have an L1 after it. Once it says that, then you hit enter and all of this data will come up. So the 5-number summary, we're going to need to scroll down, is the minimum, the first quartile, the median, the third quartile, and the maximum. So the word quartile means a quarter of the data. So if you want to compare this to money quickly, if you think about $1, if you split it up into quarters, you would start with 0 cents. That would correspond to the minimum. 25 cents would correspond to the first quartile. 50 cents would correspond to the median. 75 cents would correspond to quartile 3. And $1 would correspond to the maximum. So you just need to list these 5 numbers as the minimum is 7, Q1 is 13, median is 17, Q3 is 19.5, maximum is 23. The range would be the minimum to the maximum, the median, and then half of the data. If we go back here, from quartile 1 to quartile 3, from 25 cents to 75 cents is 50 cents. That's half of $1. So half of the data is between 13 and 19.5. Similarly, half of the data is between 7 and 17, or 17 and 23. Between any 2 points on here, not 2 points, but if you go from a point, skip one, and go to the next one, that's half of your data. But typically, you use Q1 and Q3 to talk about the middle 50% of your data, so 13 to 19.5. Here's a check your progress problem. Go ahead and pause the video, read through it. You're going to have to do the same type of stuff we just did in this example. You'll see the answer on the next screen. Okay, our answer this time is choice C. If we are using the mean and standard deviation, that means this was a symmetric distribution. The mean and the standard deviation are also in the 5-number summary. Let me scroll up back from the first data set. The mean is X bar, it's 16.1 from our first one that we did, and the standard deviation is SX, 4.1 from ours. But again, from the one that we did, we had to use the 5-number summary. We did not use the mean and the standard deviation. But that's what you get them from the same one variable stats command on the calculator. We're going to go ahead and pause the video. We ran out of time. We're going to pick up example 2 in the next video.